Robot Talk is the podcast that sits down with roboticists from around the world and asks them the questions you always wanted answered. Like, can it act autonomously? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and in today's episode, we're broaching one of the most contentious topics in robotics: robots in the military. I'm exploring the technological and ethical issues that arise when robots are deployed in military operations, and how those robots are also putting their skills to use in humanitarian and disaster response settings. I know that this topic can be quite divisive and emotional, so if you'd prefer not to listen, that's totally fair enough. I decided to cover this topic because, for better or worse, robots are being used by militaries around the world, and I think it's important to be able to have nuanced, rational conversations about what that means and what is or isn't acceptable. I hope that you'll find this interview interesting and informative. I certainly did. So, with all that said, it's time for me to introduce this week's guest. I recently had a thought-provoking conversation with Gavin Kenneally from Ghost Robotics about robot dogs for defense, security, and public safety. This week, I'm talking to Gavin Kenneally, CEO and co-founder of Ghost Robotics, a company developing durable and agile ground robots for defense, security, industrial, and public safety applications. Hi, Gavin. Welcome to Robot Talk.
Hi, thank you, Claire. Great to be on.
So, Ghost Robotics has really made a name for itself in developing rugged quadruped robots that can handle all kinds of different terrains and all different kinds of weather. The prime example being your flagship product, the Vision 60 Q-UGV. So can you tell us a bit about this robot and its capabilities?
Absolutely. When we founded the company early on, we were really thinking about how to make a legged robot that would be useful for customers as opposed to something that's just kind of a generic system that was designed by engineers in a conference room. And so we iterated very closely with some of our first customers for a few years to build a system that would be helpful in real world scenarios. One of our first customers was Navy Special Warfare. So it's the team that trains the Navy SEALs. We were actually able to build early prototypes and then take them to exercises with these customers in simulated use cases to get that feedback early on and iterate really quickly. So we did this for a few years, and it led us to building the Vision 60 robot that we continue to sell today. And some of the important differences that we highlighted with this customer feedback are really around endurance, ruggedization, and open architecture. So endurance, our robot can operate for 3 hours of continuous walk time, 24 hours standby time. So that's class leading from a legged robotics perspective. You know, early on, we had built prototypes that would last 20 minutes or something like that. So it was a significant engineering effort for the team to get the endurance up that much. In terms of ruggedization, we also spent a lot of engineering effort to make sure that the robot is fully sealed. So it's sealed to IP67, which actually means that the robot can operate in up to 1 meter of water. So this was a multi-year endeavor. We actually had a kind of a dunk tank that we built for the robot that was about a meter by meter by meter. And we would build prototypes, dunk them in the water, take them out. You know, they would leak and it would be very kind of frustrating for us, but we kept iterating and eventually figured out how to seal all the interfaces and joints of the robot. And that's important, not because the robots are necessarily going to be fording rivers, although they might, but it just represents, you know, really the most adverse environments that they see in applications of their customer base. And then the third one is really an open ecosystem. So the ability to not dictate to the customers certain pre-made payloads or sensor packages, but just have an open system so that it's really easy for customers to add different payloads and kind of interface with the robot through the SDK.
Okay, like a kind of modular design then in terms of the payloads.
Yeah, exactly. So modularity is one of our major themes. So the payloads are modular. We built the legs in a modular way as well. So thinking about customer use cases, right, in real world environments where we have these robots moving around in difficult conditions, it's really not a question of if, but eventually when something is going to break. And so we've designed the robot itself to be modular in terms of payloads, but modular in terms of its own construction as well. So if a leg breaks in the field in under 5 minutes, you can swap out a new leg. You don't have to send the robots back to us, right? I think basically all of our competitors, anything that goes wrong, you have to send the robot back to them. We really wanted to make sure the customers could be as independent as possible.
Yeah. Okay. I saw lots of news stories about the fact that you've recently added a robotic arm to the quadruped. So do you want to talk a little bit about that?
Yeah. So one of our themes for our customers, you mentioned kind of a highlight of different customers, both on the government and commercial side. But one of the common themes is really for the robot to be able to go anywhere and keep humans out of harm's way, right? So whatever the dangerous environment is, whether it's on the government side or industrial, we want to send the robot into the dangerous environment, keep the humans back and keep them safe. And so having the robot be kind of as unstoppable as possible in terms of getting over all kinds of difficult terrain and rough terrain in the outdoor environment or stairs or things like that, that's what we spent a lot of our time working on. And so for several years now, one of our common issues is that the real world has a lot of doors and the robot by itself is not able to open doors. So we spent a lot of time building a robot arm that was pretty well tuned to do door opening. So that was what motivated the arm originally, was to be able to have the robot continue to move around in the environment, push things out of the way, open doors, kind of interact with the environment. And this is really a huge value add for legged robots specifically, or ground robots, compared to small UAVs or drones, right? Because those are really not able to exert any kind of force on the world around them. They have to really operate only in free space. But the nice thing about legged systems is they can push through things like curtains, they can open doors, they can really kind of increase their mobility by doing some amount of manipulation on the platform.
Mm-hmm. It's interesting because the moment that I think about a robotic arm, I think about picking things up or manipulating objects. I think it's funny that the real challenge is opening doors.
Well, it's really all of the above. I mean, we have customers who think about the robot arms for kind of more manipulation use cases, like you're saying, right? If it's CBRN, so chemical, biological, radiation, or nuclear threat detection, you often have to go into a really dangerous environment that you don't want to send humans and then take a sample or grab something. So that is kind of more of a manipulation type task, as you're saying. And then a really surprising one that we didn't think of that actually came from our customers was, if you think about the size of the robot, it's about 100 pounds. It's kind of the size of a large dog. And all of the sensors are mounted on that robot. So from a human perspective, they're kind of somewhere between your knees and your hips. So they have kind of a low vantage point. Well, when you add an arm on top of that, one of the pieces of feedback we got from customers is make sure that there's really good sensors at the end of the arm as well, so that you can kind of look around, not only in terms of moving the camera around, but looking around corners or looking around at kind of more of a human eye height. If you're doing industrial inspection, right, all of the gauges are going to be designed for the human operators going around and observing them. So you need to make sure that you can kind of manipulate your cameras as well and get them to a reasonable height.
Yeah, that's a good point. I wouldn't have thought of that either. So, one of the use cases for your robots is in the military. And obviously, the use of robots in the military can be quite a contentious topic. And I think there are really interesting and nuanced ethical arguments on both sides of that. And I'm always keen in the podcast to try and step away from the sort of sci-fi version of robotics and talk about the reality. Now, where other robotics companies have signed a pledge to not weaponize their robots, Ghost Robotics remains open to that possibility. So could you kind of explain your stance on this issue?
Yeah, absolutely. I guess I'll address the pledge first and then talk about Ghost Robotics and our policy.
Mm.
So I think that the pledge itself, I think, was quite cynical and was a bit of a PR move. If you look at the companies that did sign it, one of them, Boston Dynamics, has been funded for many decades by the U.S. DoD and DARPA, and it's publicly available that this is where they got a lot of their funding, and they really wouldn't exist as a company if not for this support from defense customers over the years. And then only once they reached kind of a level of maturity where they were moving into industrial applications that they kind of draw that line in the sand. So I see that a little bit cynically. And one of the other signers, Unitree, they've not prohibited the People's Liberation Army in China from weaponizing their platforms.
Okay.
So it's frustrating for me to see, these other companies that are kind of pledging to do one thing and then their actions are very different. So at Ghost, we want to make sure that we're extremely consistent. We've really had the same beliefs the whole time, where our focus early on was nearly exclusively government customers. We've now diversified and we do government and commercial. But for government customers, our North Star is really keeping people out of harm's way and doing our part to support U.S. and allied democracies. And so sometimes that means allowing our governments to responsibly use force on these systems. And there's a couple of recent examples in history that we can kind of look at and see what we're referring to. So, when the Russian invasion of Ukraine started, all of the experts were saying, is it going to be a matter of days or is it going to be a week or two before the Russian tanks are storming through Kiev? And obviously we know it's been 4 years. That hasn't happened. And really that's to do with the resilience and the creativity of the Ukrainian people, but also their use of improvised UAVs with some amount of lethal force. And so technology and warfare have always been related. And for us, we want to do our part to support these democracies and remove people from harm's way. The other example that I mentioned is Taiwan. And there's this video and kind of piece of propaganda that was put out of these weaponized legged robots doing a simulated invasion of Taiwan. Do we really want to have the Taiwanese army of humans facing these weaponized legged robots and kind of having that overmatch where they're not able to have the same kind of capabilities? I would argue no. We want to make sure that our U.S. allies that are thriving democracies are able to defend themselves and have the capabilities to do so. So at Ghost Robotics, we're trying to support that.
Mm-hmm. I mean, obviously, I completely see the argument that robotics can take people out of harm's way. And if it's a choice between having two humans fighting or having two robots fighting, I know which one I would prefer. For me, one of the key aspects of this debate is autonomy, because I'm kind of comfortable with the idea of, a robot that has a gun on it or whatever, it's been weaponized, that's in sort of remote control of a human. That's just taking the human out of the way in my mind. But if that robot could have autonomous capabilities and to use that weapon without direct human involvement, that's where I start to feel uncomfortable, I guess. So, where do you stand on this issue? And could the Vision 60 potentially be used as an autonomous weapon in that way?
No. So the policy here is very clear. And I'll focus on the U.S., obviously, since we're located in the U.S. and it's our biggest customer. But in the U.S., the policy around this is DoD 3000.09. And it outlines basically the ethical use of force with these semi-autonomous systems. The number one most important thing is exactly as you identified, that there is a human in the loop making these extremely critical decisions. But then the policy actually it has 5 main pillars and goes into the detailed thinking of how to make sure these systems are being used in ethical ways. So the first pillar is responsibility, having the personnel exercise appropriate levels of judgment and care while remaining responsible for their decisions. The second pillar is equitable. So the DoD is taking steps to minimize any unintended bias in the capabilities of the system. The third is traceable. So you want to know exactly what happened to be able to audit the data and sources and kind of procedures and documentation around the use of these systems to make sure that you can understand after the fact exactly what happened. The systems need to be reliable. That's extremely important, right? You want, when you give the system a command to do something, you want to make sure that's going to happen. And then the last pillar is governable. So the systems are doing their intended functions while having the ability to detect and avoid unintended consequences. So this is really the governing policy in the US. And as Ghost Robotics, this is kind of our guiding principle for our customers. So, we defer to our customers, and in a democracy, it's our elected officials who are making these policies. In the US, we happen to know and review the relevant policies to what we're doing with our government customers.
Mm-hmm. It's probably worth mentioning that obviously there are many ways you can use robots in military applications that don't involve weaponizing them. Do you want to talk a little bit about some of those use cases?
Yeah, absolutely. That's actually the majority of the use cases that our customers have. So we really think of it in two main categories. The first one is persistent system. So having a robot that actually does basically the same thing day in, day out. So the big one there is really perimeter security. So we've done several contracts with the Air Force to do perimeter security at several different Air Force bases. Before they were using robots for this, it was actually airmen or airwomen who were tasked with going out and walking the very large perimeter of these bases and just kind of make sure that nobody jumped the fence or there wasn't some damage or something like that. Not a great use of time of these highly skilled people. And also there's some danger associated with this as well. So part of our efforts there are having our legged robots actually go and do these patrols around the perimeter. We have cameras and microphones on board the robots, and we're actually able to use some of our AI capabilities at the edge to detect if there are any audio or video anomalies of what's going on, and then alert the human operator. And it's ultimately the human operator's decision what to do, if they want to take direct control of the robot and go kind of more precisely look at what's going on, or reroute some of the robots that are on their patrol routes. So it's a good example of, you're amplifying the capabilities of a human by having one human control, a fleet of robots doing perimeter security, and they're keeping them out of harm's way. So that's one kind of bucket of use cases. The other is more ad hoc. So ISR is the big application there, which stands for intelligence, surveillance, reconnaissance. So this is not in a persistent way, but in a more ad hoc fashion. Let's say special forces, need to get information about a given environment. They would send the robot to go look ahead and get that situational awareness instead of going themselves as a human being. So this increases the standoff distance, which improves safety. There's also breaching scenarios, which is if you have to go inside a building. And this has been well studied. It's called the fatal funnel, where typically the first two people that go inside a building in a breaching scenario experience 70% or more of the casualties. So it's an extremely sensitive and extremely dangerous scenario. And so what we're working on with our customers is really have the first one or two things that goes through the door. Don't have them be people, have them be robots. Send the robots into this extremely dangerous environment. You can kind of get the situational awareness that you need with onboard regular cameras, thermal cameras, microphones, other sensors. You could sense if there's any poisonous gases, anything like that, where you get a really full picture of the kind of level of danger. And then if it turns out that there's an enemy combatant in that building, shooting at the door, then the robot gets shot instead of a person, right? And so for us, that's really the kind of ultimate success, is that a robot takes a bullet instead of a human being.
Yeah, absolutely.
So those are kind of the two main buckets. We also do some work in CBRN more explicitly. So it's chemical, biological, radiation, nuclear threat detection, sometimes kind of more ad hoc and sometimes in more persistent applications. And then some amount of explosive ordnance disposal as well.
Okay. Yeah, a lot of really, really important roles. So an issue that I guess affects robots, whether they're in defense, security, industrial applications, is the risk of kind of being hacked by a hostile actor. So what kind of cybersecurity features does the Vision 60 have to prevent this from happening?
Yeah, so at Ghost Robotics, we're a pretty small team. We're 60 people. We're mostly focused on building the robots. The security vulnerabilities really tend to be with the network hardware. So whatever radio you're using to command the robots and tell them where to go. So we actually we bundle in a basic radio for some customers that has 4G and soon to be 5G capabilities. So those are extremely secure, right? 4G, 5G is just kind of everywhere and extremely hard to penetrate. And that's what most of our commercial or industrial customers will end up using. But then for the government side, there's a whole industry of companies that make radios specifically for government customers. Governments already own these radios. There's companies like Silva Systems or Persistent Systems. And basically, we just leverage these radios on our robots. And that way, all of the security, authentication, everything that they've done, we're kind of piggybacking on those capabilities and leveraging them for our customers because we just don't have the bandwidth to replicate that in a company of our size. So it's all about really finding the right partners who have a really proven track record of extremely secure communication systems and then integrating those into our robots.
Yeah. And, why bother reinventing the wheel when they've already done all that hard work?
Yeah.
So, your robots are also being used in humanitarian and disaster relief applications. And one example was the use of the legged robots to deliver supplies and search dangerous areas in the wake of the devastating earthquake in Japan in 2024. So can you tell us a bit more about this mission and more generally about the company's work in this area?
Yeah, absolutely. So this was through one of our customers, the Japanese Self-Defense Force. They've purchased several robots, actually both for perimeter security type applications, as well as these more ad hoc applications that were necessary during this earthquake. And yeah, basically during the earthquake, obviously there was significant damage to the buildings and infrastructure. And so the robots were actually used to guide the civilians and kind of help them understand what the safe evacuation route was. So it was having the robots move around and basically kind of go back and forth to draw attention and then have the people follow the robots back through the evacuation route. So kind of amplifying the ability of the first responders to do their job by having robots moving around as well as doing this themselves. There was another earthquake in Myanmar, I believe in 2025, and our other customers had very similar applications and using the robots for disaster relief during that earthquake. Now, we've had a wide variety of these type of instances. There was one of our customers is the Spanish National Police. They actually had to deal with a battery fire where, unfortunately, it was an electric vehicle in a parking garage and something went wrong with the battery that caught on fire and unfortunately took the life of 2 firefighters before they sent in the robot to get the kind of situational awareness and understand what was going on. And of course, the poisonous gases weren't a problem for the robot. So this is really kind of a meaningful work to us where we can show that we're putting the systems in these extremely dangerous scenarios where you can get the information, kind of intelligence that you need to understand what's going on and then make all those decisions while having humans further back from harm's way.
Yeah.
So those are some of the kind of more intense examples of where robots have been used for disaster relief type applications. But there's also the much more mundane. I mentioned that we have robots doing perimeter security at Air Force bases, but we've also been increasing our footprint on the commercial and industrial side of the business. And it turns out that building these highly ruggedized robots for Air Force customers, they're almost the same needs in industrial environments that are extremely, where you need an extremely rugged platform. So, for example, construction, mining, oil and gas, where they have a lot of the same use cases. So we've been scaling up doing perimeter security type applications as well. A lot around data centers as those are being built up. They tend to be in more remote areas where you need to make sure that there's good perimeter security around those facilities, or even in an oil and gas environment as well, you can have the robots getting situational awareness, not only that the facility is secure, but then kind of while you're there, the cameras and the other sensors can also do basic diagnostics of the equipment. And so the human repair technicians, they don't have to spend their very valuable time just checking gauges and checking temperature of equipment and making sure there aren't poisonous gases that are leaking. The robot can consistently do those checks and gather very high quality and regular data about the facility. And then the humans can focus their time on actually repairing when things go wrong. So it's really kind of leveraging the best of the robots and the best of the employees to be more productive as a team.
Mm-hmm. Yeah. Coming back briefly to the humanitarian applications, from a kind of social robotics perspective, I imagine that there'll be massive cultural differences between how people might react. If you're trapped in a collapsed building, say, and a robot turns up to lead you to safety. In Japan, they have readily embraced robots. They're very comfortable with them. I imagine the response will be positive. But maybe in some other countries, or people with different backgrounds, different experiences might not necessarily find that as reassuring.
Yeah, that's interesting. I think, to some degree, science fiction has kind of primed us for robots as necessarily being some kind of, evil character. So I think there is some amount of bias in people's minds in that direction. But what's amazing is as our customers get to use the robots, and as there's kind of more familiarity, or even we do a lot of outreach events with kids, you really don't see this with kids. The kids are very excited that it looks like a dog, but it's kind of a robot, and it's just kind of very exciting to them. And then as people use the systems, they tend to get much more comfortable. We do a lot of technical support, obviously, with our systems to help customers, integrate different payloads. And we'll get technical support emails pretty frequently that say something along the lines of, I was trying to attach a thermal camera to Fluffy and I plugged it into the Ethernet port, but I don't know, what drivers should I use or something like that. And it kind of takes us a second to realize that these customers very readily, as soon as they get the robot, they'll give them pet names.
Yeah.
They kind of connect as they use the system. So I think there's certainly some amount of kind of cultural bias, but as people actually use the systems, get more familiar, understand what the systems can and can't do, that people tend to have kind of a more positive view over time. I think the biggest misconception is really around autonomy. These systems are not autonomous. They are really kind of remote data collection systems where either it's being driven one-to-one by an operator or it's being commanded to do a certain patrol route. And if there's really anything out of the ordinary, immediately the operator gets pinged to make any decisions. So I think that really gives people comfort that it's kind of how to have an effect at a distance while keeping people out of harm's way.
Yeah, I mean, I guess our brains are primed to kind of anthropomorphize robots and to give them little characters. And I guess that can work in a positive or a negative way, depending on the person and the context. So what is on your wish list next for your quadrupeds? What features would you really like to add? What things are you working on right now?
Yeah, so we're a small company, but we have a lot of engineers, and with a very motivated team of engineers, it's the challenge is less what are we going to do next, but it's more let's focus and just do one thing next and not kind of let everybody run wild with all their crazy and fun ideas for next generation products. So we do try and stay extremely focused. But that being said, we also really enjoy innovating. So I mentioned, for years, we would build several versions of the robot every year, do customer testing, and then iterate really quickly. We have slowed the pace of that a little bit as the hardware has gotten more mature, but there's still a huge amount for us to do on the software side. So that's really what I'm most excited about is the software on the robot itself. So the ability to move around better over increasingly more difficult terrain. We have quite a bit in the pipeline there for improved performance over rough terrain. And then now that we've added the arm, as we talked about, the first thing most customers do will be door opening. Now we have some basic software that we've written around kind of semi-autonomous door opening. But by putting the arm on the robot, it has also exposed us to just how many possibilities there are of being able to move around as a system that can move over rough terrain and also do basic manipulation of the environment. You see this in the explosive ordnance disposal community, where historically it's been tracked robots that will, let's say if there's an object that might be an improvised explosive device, there'll be a tracked robot that kind of slowly drives up, and then very carefully you'll see a robot arm doing something like cutting a wire or using a compressed water cannon to destroy the explosive without setting it off. The way that those systems are controlled, it's really amazing that those operators are so good at doing that, because they're actually controlling each individual joint separately.
Wow.
So it's a tremendous amount of training, and they're extremely skilled operators. Yeah. Well, for us, there's a huge opportunity there to figure out what are the better ways to do this manipulation at a distance where the robot is moving kind of in synergistic ways or using the onboard sensors to augment the human's control. So this is a huge area of study in academia, and it's really new to us as a company. So I think that on the software side there's lots of room for improvement, and we're doing active development in simulated use case testing that we run, multiple times per week, and we just kind of keep collecting data and taking feedback. One of our pillars of innovation is just having the feedback loop between having a new idea and testing the new idea in a kind of a simulated use case, having that feedback loop be as short as possible so that we can kind of test things and innovate quickly.
Yeah, I mean, that bomb disposal example is really interesting and really important. I'm sure I will see more news stories and updates and developments from Ghost Robotics in the future. Gavin, it's been fascinating chatting to you today. I've been speaking to Gavin Kenneally from Ghost Robotics. Thank you.
Wonderful. Thank you so much for having me on, Claire. It was a pleasure.
Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast, subscribe, and leave a review. And check out @RobotTalkPod on social media to see a photo of Ghost Robotics' Vision 60 quadruped robot, designed for challenging terrain. Next week, I'll be speaking to Josie Hughes from EPFL about generating new robot designs. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk Season 6 is sponsored by the Hamlin Centre, Imperial College London.